morning student. Today we will discuss colligative properties. Colligative properties. What do you mean by colligative properties? That means definition of properties. Solution having different properties. The sum of the properties depends upon the numbers of particles. That means definition of colligative properties. The properties of solution that depends upon numbers of particles, of solute. They may be molecules or ions, and do not depend upon nature of solute. That means it is independent of the nature of solute, only depends upon the number of particles of solute in a solution. If the numbers of particles of solute in solution is same, nature of solute will be whatever may be, it will be different or same, on which it does not depend. If the numbers of particles are same, then the value of properties is same. There are four qualitative properties we have to study. The first one is relative lowering. In vapor pressure of solvent. Second property is elevation in boiling point of solvent. Third one is depression in freezing point of solvent. And the fourth one is osmotic pressure of solution. Okay. The relative lowering in vapor pressure of solvent, that means it is known as RLVP. That means relative lowering in vapor pressure. Elevation in boiling point of solvent, that means it is known as delta TB. Depression in freezing point of solvent is known as delta TF. And again osmotic pressure of solution, which is known as pi. Now colligative properties means depends upon numbers of particles. If the numbers of particles are same, then colligative properties are same. Say example, glucose. Okay. When glucose dissolved in water, that means it will be dissolved. There is no change in numbers of particles, only dissolves. Suppose 1 mole glucose is dissolved, and then numbers of particles will be is equal to Avogadro number. Suppose we are considering 1 mole glucose here. 1 mole glucose. Okay, 1 molar glucose solution. Numbers of particles equal to Avogadro number. Now, if we consider the 2 molar NaCl solution, okay, then solution, when NaCl dissolved in water, it will be ionized. That means it gives Na plus and Cl minus. That means numbers of particles become 2 from 1. One NaCl molecules, it gives Na plus and Cl minus. That means in case of glucose, numbers of particles remain as it is. In case of when NaCl is dissolved in water, the numbers of particles becomes double. Concentration is same. Here also concentration is same, 1 molar. Okay, 1 molar glucose, so 1 particle, 1 molar NaCl solution. That means Na plus Cl minus. So numbers of particles becomes twice. Suppose we are considering K2SO4. So in case of K2SO4, it also ionizes 2K plus and SO4 minus 2. So numbers of particles 2K plus and 1 SO4 minus 2. That means numbers of particles 3. Suppose aluminum nitrate solution is there, then A plus 3 NO3 minus, that means 3 NO3. The numbers of particles becomes 4. Again, aluminum sulfate is considered Al2SO4 thrice, then 2Al plus 3 3SO4 minus 2. Numbers of particles are 5. That means when dissociation takes place, numbers of particles will be changed. So here considering example of glucose and NaCl. In case of glucose, numbers of particles is 1, NaCl 2. So if we are considering the colligative property, suppose elevation in boiling point, remaining all properties are same, that means concentration is same. Suppose 1 molar glucose solution, 1 molar NaCl solution, and we are comparing the elevation in boiling point, that means delta Tb. So compared to glucose, in case of NaCl, the delta Tb value will be twice. Reason numbers of particles is double. Again, we compare with the K2SO4 solution. If the concentration is same, under the same identical condition, and if we compare the colligative properties, suppose elevation in boiling point, then elevation in boiling point in case of K2SO4 solution is thrice compared to glucose. That means suppose here value is 0.01 and here it will be 0.03, 3 times. 3 times colligative property compared to glucose. Suppose we consider aluminum nitrate solution, then it having 4 times the value. Again aluminum sulfate, to it having 5 times the value. That means it depends upon the numbers of particles. Here we are assuming completely dissociation take place. Now again we consider suppose osmotic pressure. Similarly, concentration is same under the same identical condition. If we measure the osmotic pressure of glucose and NaCl, then the NaCl solution having twice the osmotic pressure compared to glucose under identical condition, result numbers of particles becomes double. That means colligative property depends upon only on the numbers of particles of solute present in solution. If the numbers of particles of solute present in solution is same, equal, then the value of colligative properties are same. And if the particles becomes double, then the value of colligative properties becomes double, and so on. This is the concept of colligative properties. We have to discuss the 4 colligative properties. The first one is relative lowering in vapor pressure of solvent. That means RLVP. That means relative lowering in vapor pressure of solvent. Now we are considering one means solvent. One component solvent, two component solute. We are taking solute as a non-volatile. Solute is a non-volatile. Non-volatile solute means it is in solid form. Solid form. Solvent is volatile. Solvent is volatile, it is in liquid. So when we are dissolving non-volatile solute in a volatile solvent, then what happens? Now, what is P1? So P1 is the vapor pressure of solvent. P1 0. P1 0 means vapor pressure of pure solvent. Vapor pressure of pure solvent. Now, solute is non-volatile. That means solute does not have the vapor pressure. Now we are adding non-volatile solute in volatile solvent for the formation of solution. The vapor pressure of the solvent will be changed. That means it is P1. So P1 is vapor pressure of solvent after addition of solute. Sometimes also we can say this is the vapor pressure of solution. Vapor pressure of solution, because when non-volatile solute is added in volatile solvent, the solution is formed. That means we are calculating the vapor pressure of actually solution, but this is the vapor pressure when non-volatile solute is added and vapor pressure decreases. That means here P10 and P1. So we know very well which value is greater. So always P10. P10 is greater than P1. P10 is greater than P1. Vapor pressure of pure solvent is always higher compared to vapor pressure of solvent. That means after addition of non-volatile solute. Because in pure solvent, only solvent molecules are there. That means solvent molecules will be vaporized from the surface. When non-volatile solute is added, that means the surface, some of the space is covered by solute molecules. That means the numbers of molecules which are converted into vapor from the surface, it is decreases. And again non-volatile solute is added. That means intermolecular attraction is also there, and the numbers of molecules of solvent which are vaporized decreases. Suppose pure solvent, that means at the surface only solvent molecules, and non-volatile solute is added, then some of the space of surface is covered by non-volatile solute. The numbers of molecules of solvent which are converted into vapor are decreases. That means always remember, when the non-volatile solution is added in volatile solvent, then vapor pressure is decreases. That means always P10 greater than P1. That means P10 minus P1 equal to delta P, and delta P is known as lowering in vapor pressure. Lowering in vapor pressure. Now what do you mean by relative lowering vapor pressure? So relative lowering vapor pressure means we have to compare with the solvent. Initially we have solvent, we have added non-volatile solute to compare to solvent. That means delta P divided by P10 is known as relative lowering in vapor pressure. This quantity is known as relative lowering vapor pressure of solvent. Now how to calculate relative lowering vapor pressure of the solvent? So we know very well Raoult's law. As per Raoult's law, when Raoult's law applied for the solvent, because solvent is volatile, solute is non-volatile. So we know very well Raoult's law. In a liquid solution, the vapor pressure, the partial vapor pressure of the volatile component is directly proportional to its mole fraction in the solution. That means P1 proportional to X1. Again, we know proportionality constant P1 equal to P1 0 X1. This is based on Raoult's law. Now we have to calculate the relative lowering in vapor pressure. That means delta P, first we calculate delta P equal to P1 0 minus P1. Now again P1 0. P1 equal to P1 0 minus X1. So P1 0 X1. Now P1 0 is common, that means P1 0 1 minus X1. Now delta P divided by P1 0. P1 0 is written here, so equal to 1 minus X1. 1 minus X1 equal to X2. That means delta P upon P1 0 equal to X2. That means relative lowering in vapor pressure. Relative lowering vapor pressure equal to X2. X2 means mole fraction of solute. Mole fraction of solute. That means when non-volatile solute is added in volatile solvent, then relative lowering vapor pressure is equal to the mole fraction of solute in solution. Now mole fraction of solute is X2. So how to calculate X2? Now W1 that means mass of solvent M1 is the mass of molecular mass of solvent. That means N1 equal to W1 upon M1. Similarly W2 means mass of solute, N2 means molar mass of solute. Component 1 component means solvent, 2 means solute. That means N2 equal to, can be calculated as W2 upon M2. Now here substituting value, delta P is P1 0 minus P1 upon P1 0. Now X2 means mole fraction. Mole fraction of solute can be calculated as moles of solute divided by total mole of N2 plus N1. Now P1 0 again minus P1 upon P1 0. This formula is important. Again P1 0 minus P1 divided by P1 0 equal to N2 means W2 upon N2. Again W2 upon N2 and the W1 upon N1. Now for dilute solution. Dilute solution is the amount of solute which is present in solution is less. That means N2 less than N1. That means here we can neglect the value of N2 compared to N1. That means N2 plus N1 here is less than N1. That means P1 0 minus P1 upon P1 0 equal to N2 upon N1. Therefore, P1 0 minus P1 upon P1 0 equal to N2 means W2 upon N2. Again, N1 means W1 divided by N1. W1 divided by N1. This is complete formula for Raoult's law when non-volatile solute is dissolved in volatile solvent, and this formula can be used when solution is dilute. If P1 0 is known, P1 is known, W2 M1 W1 is known, then we can calculate the molar mass of the solid. This is the one of the method to determine the molar mass of solid. Now dilute solution is generally when the concentration of solid is less than 5%. Then it is considered as a dilute solution. Otherwise, concentrated solution to use complete formula. This one, and for dilute solution you can use this formula to calculate the molar mass of solid.